Assalamu alaikum. I hope you're fine and healthy. Today we will start our playlist for the Mathematics 8th grade National Book Foundation 2022. So this book was released in 2023, the latest third edition, and we will be covering it chapter by chapter. So today we will start the series by first chapter. The chapter is called The Set of Real Numbers. If we look at the title page, real numbers, it has a very elaborate rational number Venn diagram. It tells us the story of number system, how the rational number system has a subset three number system. The first system is the natural number system. Natural number system is the basic number system that has the counting numbers 1, 2, 3 and up to so on. If we add a 0 to this system was called the whole number system. It starts from the 0 and goes to the infinity, just like natural numbers. As we progress in mathematics and we counter negative numbers, a new number system integer was developed for a number that has positive as well as negative numbers. Such a number system is called set of integers. And then if any number system has not only these numbers 0 and negative number, but also the fractions like p by q, any number that can be written as the form of p by q, that number is categorized as a rational number. The p and q are any integers. We must remember that the set of natural number, whole number and integer are all subset of rational number. That means if I take any natural number, for example if we take 1 or 2, we can express it in the form of p by q. How? If we give 1 at its denominator, then now it is expressed in the form of integer, and now in the form of fraction, it is called now a rational number. Similarly, any negative number, if we put minus 1 divided by 1, minus 5 divided by 5, these are all the same numbers, integers, but also can be represented as a fraction. So these all numbers are actually rational numbers. So we can represent them as this system of Venn diagram where the whole number have a subset natural number, whereas the integer have the subset natural number as well as the whole number, whereas the rational number are the superset for natural number, whole numbers and integer. All three sets are included in it. This was the story of rational number. Rational number are represented by q. There is a third category of numbers that are called irrational numbers that are represented by q prime. All those numbers that cannot be written in the form of p by q are called irrational numbers. What are these numbers? How can these numbers be? These are actually type of decimal numbers or the quantities that can never be represented as the what we can say as a fraction. They are also in the form of decimal. In decimal we categorize as them as non-terminating and non-recurring decimal system. These are called the irrational numbers. Also, for example, we have this number pi. It is a ratio of circumference of a circle to diameter. This ratio is represented as pi and has a non-recurring non-terminating decimal. This such a number is called pi, and it is a irrational number. Any number that are under roots of the prime number can also be non-terminating and non-recurring, and these are also irrational number. What are non-terminating decimals, and what do we mean by these terms? Non-terminating means any decimal number that goes on and does not terminate at the end is called a non-terminating decimal, and any decimal number that does not have any pattern in it and it continues on and have a different number every time is called a non-recurring. If we look at this page number 6, we have this definitions. If we look at the terminating decimals, these terminating decimal fractions can always convert it into a fraction. Like for example, 1/4 is a terminating decimal fraction 0.25. 2/5 similarly is a terminating decimal fraction. 3/2 1.5 and 1.75. These are all examples of terminating where the finite number of digits in its decimal part. So that is the definition of terminating. Non-recurring is a single digit or group of digits repeated again and again in the same order. For example, in 1/3 we have 0.3333 and it goes on. For example, in 1/7 there is a pattern of 142,857, and again 142,857, and again this pattern is repeated. Such repeated pattern decimal fractions are called recurring decimal fraction. And if a decimal fraction is terminated, it can be represented as p/q, so it is not called irrational. And similarly, if we have a pattern, that can also be represented in the form of fraction as the process given here, which will not be discussed here, but they can also be converted into fractions, so they are also not irrational. But on the other hand, if we have non-terminating and non-recurring decimal fractions, we call them irrational number because they can never be converted into p/q or a fraction. Now if we come to the page number 9 and look at this table, we are given some numbers and we will check if they are rational or irrational. For example, if we take under root 2, this goes on to 1.4142135 and up to so on, and it categorized as non-terminating and non-recurring decimal, so it will be a irrational number. Similarly, 3/5 is a fraction, so it is a rational number. Similarly, if we look at the under root 3 has a decimal fraction 1.73205080 and up to so on, a non-terminating non-recurring decimal, so it is also a irrational number. If we look at under root 4, that goes to 2 is a natural number, and we as discussed before, it can be represented as 2/1, which is a fraction, so it is a rational number. We look at this. Under root 25 simplifies as 5, and 5/7 is a fraction, so it is a rational number. Pi, we know it is a non-recurring, non-terminating decimal, it is irrational. Under root 17, again it is non-terminating, non-recurring, so it is irrational. And this 13/21, it is in the fraction, so it is a rational number. Now what we are going to do in this exercise 1.1 is that we are going to separate rational and irrational numbers. Now if we do this, if we look at this under root 9, under root 9 simplifies as 3, which is a natural number, and natural numbers are terminated as what? Rational numbers. So I'm going to highlight the rational numbers while the unhighlighted numbers will be irrational. So this under root 9 is a rational number. 12, a natural number, which is also a rational number. 5/9, obviously a fraction, so it is a rational number. Under root 8 When we make the factorization, we see that it can be represented as a multiple of a prime radical, and prime radical is an irrational number, and when we calculate it in the decimal we see that it is non-terminating and non-recurring, so it is an irrational number. Under root 100 simplifies as 10, which is a natural number and hence a rational number. So it is also rational number. Under root 13 by 2 is a rational number, and if we prime factorize this number, what is this? 2 into 126, we prime factorize it. 126 2 6 is 12, 2 3 is 6, 3 2s are 6, 3 1s are 3, 3 7s are 21, and 7 1s are 7. So we have the prime factorization 2 into 3 into 3 and into 7. That simplifies as 3 under root 2 into under root 7. Again prime numbers radical में है and multiply by a natural number, so that means it is a irrational number. 25 by 9 again fraction, so it is a rational number. It is simplifies as 13 natural number and hence a rational number. When we factorize this 13 into 2, both radicals are prime, so it is irrational. So here we have 1 2 3 irrational numbers. These are non-terminating, non-recurring decimals. You can also use the method of prime factorization. Also you can use the calculator to check if the decimal fractions are terminating or non-terminating, or whether they have a recurring pattern or not. I have used the factoring method. You can also use calculator. Now second question, we have decimals that need to be checked for terminating and non-terminating. You can use calculator to check whether these are terminating. Terminating means the fraction needs to be ending. So here we have a calculator and we will use this calculator to check whether these decimal fractions are terminating or not. For 4 divided by 9, 0.444, we would see that this is recurring and it is non-terminating. Similarly 13 divided by 20, it is terminating. 1 divided by 6, again we see that this is a recurring pattern which is rounded off by the 9 digit, so it is actually not terminating but it is rounded off, so it is also non-terminating. 7 divided by 3, 2.333, again non-terminating. It is recurring but it is not terminating. 1.25, it is terminating. 13 divided by 8, again terminating. 11 divided by 15, again non-terminating. 7 divided by 11, that is non-terminating. It is rounded off but it is non-terminating. It is recurring. Now Since we have identified these, terminating and non-terminating, now we have the task to identify them as rational and irrational. And we have to remember this, that for irrational, a number has to be non-terminating as well as non-recurring. So if we look at this number, what we can see is, again we will be highlighting rational numbers and leaving the irrational numbers. So if we look at this, it is a terminating decimal fraction and it has no pattern in it. So that means it is what? Since it is terminating, so it is rational. Recurring, so rational. Look at this again. It is non-terminating and we do not see any pattern in it, so it cannot be rational. Look at this, non-terminating and non-recurring, that means it is irrational. Look at here, we do not see any pattern and it is also continuing on, non-terminating and non-recurring, irrational. If we look at here, it is continuing on but it is recurring, so it is what? A rational. And look at this, sorry, if we look at this, it seems to have a 14285 1242857. It is exhibiting a pattern, so it becomes rational. And if we look at this, it does not have any pattern and it is continuing on, so it is irrational. We have 1 2 3 irrationals, other 4 are rational numbers. So this is it for the today's lesson. We have done set of what? Separating real and separating rational and irrational numbers. We have identified terminating and non-terminating. We have identified recurring and non-recurring. So this is it for today. Hope for the next lesson.